Okay, thanks very much and good day, everybody. My name's Ether. I'm founder and managing director of Automedi, but I'm also a mathematician working in the health economics space, specifically looking at the effects of climate change on health economics and the healthcare service more generally. Last year, the NHS released its net zero plan. Its aim is to become the world's first net zero health service. In it, it acknowledged the size of its carbon footprint. And to put this in context, its 24 million ton carbon footprint is the same as 2.9 million UK households. That's a huge amount of energy and emissions. But also, it emits, or rather disposes of 133,000 tons of plastic, of which only 5% is actually recycled. That's worse than the worst performing local authority in Britain. And it's not such a meaningless number. It's not a victimless crime. Now, healthcare is in the unique position that every other sector dumps the effect of their carbon dioxide on the health service. Both downstream and upstream waste all contribute rather to the carbon dioxide emissions that lead to people walking in through the door with respiratory disorders or heat stroke or other types of disease. Even the NHS itself does it. The NHS's emissions have nowhere else to go but into the NHS itself. And this comes from two largely similar but equally disparate parts, which exist both upstream and downstream of the patient. Upstream includes all the processes associated with the extraction, containment, transportation, manufacturing, and freight and logistics of plastics and plastic products associated with care, or any other material, in fact. And the downstream impacts are associated with transportation, energy incineration, and the effects therein. Both of these create a large proportion of the NHS's carbon footprint, and each of those then results in around £345 million of respiratory treatment alone, not any other potential disease models that may come through. Because that means everybody who's had asthma, COPD, bronchitis feel the effects of poor air quality and carbon dioxide on them every single day. And this creates a huge burden on the NHS that has a cost associated with that in financial terms. And this is because all three of health, climate change, and financial impact are related. You can't think of them in isolation. And if we look at the product life cycle, on average, it takes 4 kilograms of crude oil to make 1 kilogram of plastics. It consumes other fossil fuels through its transportation, manufacturing, storage, usage, disposal, and of course incineration ultimately. And the thinking behind this process is that it's what it is. But the reality is that if you start to break down the carbon footprints of each part of that process, you start to see where those inefficiencies lay. What you'll typically see is the justification that recovering the energy associated with this clinical waste, but nobody ever talks about what the impact of it actually is. Notwithstanding that about 22% of the waste that goes into incineration is misclassified as clinical waste, the reality is that incinerating it releases 45% of the weight of items in carbon dioxide. And of all the tons and tons of clinical waste that is incinerated every single year, that's a huge amount of CO2. Not only that, it's typically disposed of at a cost of around £3,000 per tonne. That is more than 50 times the cost of traditional conventional waste streams. And 22% of it doesn't have to be there. As soon as you incinerate it, you don't just incinerate the material, all of that stuff also goes up in smoke. This means you will accumulate more CO2 every time. Circular economics actually offers us a fantastic way to solve that. Even if you reuse the items only 2 or 3 times, you also cut out the embodied carbon that goes into the products that would otherwise have to be provided to you instead. Indeed, there are some products out there such as Sterimelt or A&B EcoSteril, which are focused very much on waste recycling, using ultrasonic baths or microwave sterilization to sterilize the waste before shredding it, and then, of course, providing the pellets for any other use. In Staymel's case, it creates blocks of plastics from the viscose and or polypropylene that is typically used within surgery. And that is simply melted down in a very large oven at 300 degrees, killing all the pathogens associated with it. But the downside to date is that those still have to be transported somewhere else for repurposing. The most effective way would be to make something at source with it. But at the moment, to date, we've not had the ability to do that. While at the same time, coronavirus exploited the fact that we had no backup supply chain. What we decided to do at Automedi was to look at repurposing the waste through 3D printing to create equipment as and when required. In essence, we take the waste that is created by these other processes, or indeed can be processed by ourselves, in essence taking this material and using it as a starter motor or starter fuel, and using it for our own manufacturing circular microeconomies, which are located at the point of use. These micro-manufacturing devices that you can see in front of you now take the waste as a consumable filament that is then placed in these machines and then used to 3D print equipment and fixtures or fittings for facilities or use within the hospital itself. This allows hospitals to have a backup supply chain. That means shortages are now a thing of the past. They can get equipment as and when required, and also gets it to you within minutes instead of days or worse, weeks. Our solution is multifaceted. There's of course the health protection aspects, the cost effectiveness, because we can produce this equipment for a lot cheaper than can normally be produced in traditional manufacturing facilities, even if they're done abroad. It reduces the risk of underruns, and crucially, it reduces the carbon footprint associated with conventional supply by up to 92%. And all of this from a really easy to use system. The health worker themselves can simply walk up to the machine, choose what they want, hit start, it'll make it in front of them. They use it, and then when needed, they simply recycle it, drop it in a bin, and we'll take it away to reprocess within the hospital facility. That then gives the hospitals the ability to create that circular microeconomy in-house. And this helps the NHS reach a lot of the decarbonisation plan targets, specifically the supply area. By reducing this large component, you create a step change towards a net zero NHS service. Dealing with that alone has a potential to cut out up to 60% of the carbon dioxide of the NHS overall. Though, of course, that has to be built up and evolved to. And extrapolating some of the early evidence that we've seen so far, Automedi is looking very, very favourable. Even comparing to PPE dedicated supply, we're still looking very, very good in comparison. It's cheaper, faster, and crucially, substantially less CO2 is emitted in that process. So we've shown that Automedi is that missing link. That allows hospitals to become their own manufacturers, basically. There shouldn't be any need to be coupled to remote factories elsewhere in the world, especially if it's cheaper than even manufacturing here. Our aim is to help the NHS get to net zero as quickly as possible. We have a versatile offering which allows organisations to place these micro-manufacturing facilities anywhere they need to within a hospital, as close to the point of care or use as needed. And with that, I'd like to summarise what we've talked about so far. Thanks very much for listening. If you want to connect with me, feel free to do so. That's my contact details. We'd love to have you on board. Obviously, this is a very large topic, and I'm happy to discuss sustainability till the cows come home. We can talk a lot about some of the health, climate, economics works we've done with other organisations, and I can even introduce you to our paper if necessary. So, with that, I'd like to thank you again for listening. If you have any questions, feel free to reach out, and have a great day.